This is part 2 of our lesson, rational functions. In this lesson, we will study the end behavior of some rational functions, or what we call the limit at the infinity. This is the graph of f of x. As we see, this graph has a horizontal asymptote at the x-axis, or at y equals 0. What value does f of x approach as x gets infinitely larger? To understand this, let's see it on a graphing calculator to see more details. This is the graph of f of x. To see more details, I will zoom in. As you see, as the value of x gets larger, the value of y approaches 0, but it never intersects the x-axis. Also, as the value of x gets smaller on the other side, the value of y approaches 0 as well, but it never intersects the x-axis. So, as the value of x gets infinitely larger, the value of y is equal to 0. Or not exactly the value of y. This is what we call the limit. The limit as x approaches infinity of the function f of x. So the limit of this function at the infinity is 0. Notice here that the degree of the denominator is greater than the degree of the numerator. Let's see another example now. In this case, the degree of the denominator is equal to the degree of the numerator. This is the graph of f of x. What value does f of x approach as x gets infinitely larger? As you see, the function has a horizontal asymptote at 3, at y equals 3, and we learned in the previous video how to find the horizontal asymptote. To find the horizontal asymptote, we divide 3x squared by x squared, and this is 3. So the horizontal asymptote is at y equals 3. Let's see it in more details. This is the graph of f of x. As you go more to the right, as the value of x gets larger, the value of the function approaches 3. But it's not exactly 3. As you see, it can never be 3. It's 2.95, 2.96, and so on. But it will never be 3. Also, as you go to the left, the value approaches 3. It's slightly more than 3, but it's not 3 at any point. So this function, the value of the function approaches 3 as x gets infinitely larger, which is the limit of this function at the infinity. And as x gets infinitely smaller, the function approaches 3 as well. In this case, the degree of the numerator is greater than the degree of the denominator. And if you remember, we said in this case, we don't have a horizontal asymptote. Because if we divide 3x cubed over x squared, this is 3x, and this function does not have an asymptote because it's a linear function. Here, as x gets infinitely larger, it means that the value of x is infinity, so the function will approach infinity as x gets larger. Also, as x gets infinitely smaller, the function will approach negative infinity. Let's see this on the calculator. This is the graph of f of x in this case. As we go more to the right, as we increase the value of x, the value of y, or the value of f of x, increases as well. So the limit at the infinity is infinity. Now, if we go to the left, as x gets smaller, y also gets smaller. So as x gets infinitely small, y gets infinitely small. Here the degree of the numerator is greater than the degree of the denominator by 1. So as the value of x gets infinitely larger, the value of the function approaches infinity. And as the value of x gets infinitely smaller, the value of the function approaches negative infinity. Now let's solve some questions about different cases. If f of x equals negative 3x squared minus 2x plus 4 over positive x squared plus x minus 5, what value does f of x approach as x gets infinitely larger or smaller? For the limits or the end behavior, we care more about the leading terms of the numerator and the denominator. To determine the end behavior of this function, we take the leading terms of both the denominator and the numerator. This is negative 3x squared over x squared. These two cancel out, so the end behavior of this function is at negative 3. I mean f of x approaches negative 3 as x gets infinitely larger or smaller. Let's prove this by graphing the function. As x gets infinitely larger, the value of the function approaches negative 3. And here, as x gets infinitely smaller, the value of the function approaches negative 3 as well. Now, this is a different case. If f of x equals square root of x squared minus 3x plus 10 over x minus 2. Don't get confused by the root. Again, we take the greatest power, but with the root over the greatest power down. The square root of x squared is the absolute value of x over x. This is equal to positive x over x or negative x over x. The first is 1 and the second is negative 1. As x gets infinitely larger, the value of the function approaches 1. As x gets infinitely smaller in the negative direction, the value of the function approaches negative 1. Let's prove it by graphing the function again. This is the graph of f of x. As you see, as x gets larger, the value of the function approaches positive 1, and as x gets smaller, the value of the function approaches negative 1. Now, this is a new idea. If f of x equals x cubed minus 8 over x to the power of 4 minus 16, what value does f of x approach as x gets closer to 0 first, then as x gets closer to 2? In this case, when we have specific numbers, we substitute the number we have in the function. Firstly, we find f of 0. F of 0 is 0 cubed, which is 0, minus 8, over 0 to the power of 4, which is 0 again, minus 16. This is equal to negative 8 over negative 16, and this is half. So as the value of x approaches 0, the value of the function approaches half. Or it might be equal to half if the function is continuous at that point. Let's see the graph of this function. So f of 0 is half, and it's continuous at this point because the function is defined at x equals 0. Now, what about f of 2? Let's substitute 2 in the function now. F of 2 is 2 cubed minus 8 divided by 2 to the power of 4 minus 16. This is 8 minus 8 over 16 minus 16, which is 0 over 0. When you get 0 over 0, when you substitute any number, it means that you need to simplify the function. If you want to simplify this is x cubed and this is 2 cubed. So the function could be simplified as x minus 2 times x squared plus 2x plus 4 over, this is a difference of two squares. This is x squared minus 4 times x squared plus 4. Again, this could be simplified. This is x minus 2 times x squared plus 2x plus 4 divided by x minus 2 times x plus 2 times x squared plus 4. These two are cancelled. This is what causes the 0 over 0. If we substitute 2 in this function, this is 2 squared, which is 4, plus 2 times 2, plus 2 times 2, this is 4 again, plus 4, divided by 2 plus 2 is 4, times 4 plus 4, which is 8. This is 12, divided by 4 times 8, which is 32. Or you can simplify it more, it is 3 over 8, or almost 0.375. Let's check this by the graphing calculator. As we see in the graph, as the value of x approaches 2 from the right, the value of the function is 0.375. As x approaches 2 from the left, again it is 0.37. Actually, for the SAT subject test, you don't need to know more details about the limit. It's enough to find the value that the function approaches or the function equals at that point. This is all for today. I hope that you understood everything in this video. If you have any difficulties, feel free to contact us. In the description box of this video, I put a link for you to upload a worksheet and test your understanding. In the next video, we will study transformations and symmetry of functions. Thanks for watching.